Let's solve MEXT.Math.A 2014 question 1.6. Okay, an integral question. So I'll be honest, I was used to the integral, the calculus question being the second question, sometimes a derivative in the third, but in the first question it's a bit weird for me. But okay, so he's telling you, let f of x be a question an equation of a of x plus b. Okay, be a linear function. And I said an equation, sorry, so a linear function if the equation of the integral of f of x dx is equal to m to this, so hold for any positive m, then f of x is equal to what? So the thing that I'm going to use is the answer. Okay, so I'm going to use the answer that he gave us. Look, he is asking you for 1.7, right? Like 1 comma 7. Like he is telling us that f of x is equal to something, okay, something multiplied by x plus something divided by 3. So I'm going to call this something a and this something b. Okay, so this is what I'm going to do. So a of x plus b divided by 3. So, and now what am I going to do? Well, I'm going to integrate it, because he is telling us that the integral of f of x dx from minus m divided by 2 to m is equal to what? Well, m multiplied by m plus 1, right? So m squared plus m divided by 2. So if I take this and integrate it, well, because this is f of x integrated, we should have something similar to this, right? So this is what I'm going to do. Now, if someone knows a better solution, I'm not anywhere good in calculus yet, so if someone knows how to do this without using this solution over here, like just taking it raw over here, maybe in few weeks I can post another solution if I learn it. But if anyone knows, you can share. Okay, so let's integrate from minus m divided by 2 to m. F of x is a of x plus b divided by 3. So let's just, the 3 is a constant, so I'm going to take it outside. Okay, so just so that we can be easier. So m, and then a of x plus b. Okay, so I took this part over here, but I took the 3 outside of the integral. Okay, so plus b dx. So let's integrate it, and remember, the integral of this must be similar to something like this. We are going to compare it later. Okay, so 1 divided by 3 of the, now let's integrate. A of x is going to be a of x squared divided by 2. From where to where? From minus m divided by 2 to m, plus the integral of b is going to be b of x from minus m divided by 2 to m. So 1 to 3. Now m squared. Okay, so am squared divided by 2 minus a divided by 2, and in the place of x squared I'm going to put this one over here. Okay, so minus m divided by 2 squared. Now plus b of x, well, b of m, and then minus b multiplied in place of x, this one over here, right? Minus m divided by 2. Okay, so 1/3 now this part over here, m minus m divided by 2 squared will be m squared divided by 4, right? So let's just m divided by 2 minus a. Now look, 2 squared is 4, multiplied by 2 is 8. Okay, so 8, and this is m squared. Remember, this negative over here is going squared, so we will still have it negative over here. Okay, so, and this is m squared. Okay, it's squared over here. Now for the next part, b. Now here it comes the thing. This negative over here, it's not squared, so this negative will become positive. Okay, so we will have bm plus bm divided by 2. Okay, now I'm going to start joining things. Okay, so here I'm going to multiply this part over here to 4 above and down. Why? So that I can sum these two. Okay, so the MMC, minimum multiple so am squared divided by 8. You see, I didn't change anything. If you divide 4 divided by 8, you will have only 2 left. Okay, but the only difference is that now I can subtract it by this one over here. So 4 minus am squared, we will have only left 3am squared, right? So I'm going to do it already over here. Am squared divided by 8. This two joint are going to give me this. Okay, so if you are doing integrals, I think you already know this stuff. And here the same thing, 2 multiplied by 2, so 2 plus 1 is 3. Okay, so plus 3 bm divided by 2. Now this is why this 3, you can't forget about it. Okay, so this 3 is going to cancel both of these. Okay, when it comes multiplying, so we'll have that am squared divided by 8 plus bm divided by 2. Now just to join everything together, I'm going to multiply here by 4 and by 4. Okay, so I'm going to have that am squared divided by 8 plus 4 bm. Now this must equal to what? To this part over here, right? Sorry, to this part over here. This must equal this. The question told us that the integral of this is equal to this, and we integrate it, so this must be equal. So let's take it over here. So let's over here. So if this is equal to this, well, let's start trying to make them similar. Okay, so we have 8 here, right? So let's multiply this side over here. Let's look, am squared plus 4 bm divided by 8 is equal to, now I'm going to multiply here 4 and divide by 4. Why? So that we can have 8 downwards. So we'll have that 8 multiplied by 4m squared plus 4m. So look, 8 and 8, and now we have am squared and 4am squared. So what I'm going to do is this will cut with this, so I'm going to have that am squared plus 4bm is equal to 4m squared plus 4m. So this, if this is a polynomial and there is a similarity, so the coefficient of the squared part must be equal to this coefficient. So a must be equal to 4, and 4b, this 4b must be equal to 4. So b must be equal to 1, and this is our answer. Okay, so our answer is 4 and 1. 4 for the 1,7 and 1 for 1,8. In the future, when I learn more about integration, I think we can solve this without using the solution maybe, so I'll try to find a way.